Hi students, let us continue the next problem on the rate measure or rate of change of quantities. Exercise 6.1. In that sixth problem, the radius of a circle is increasing at the rate of 0.7 centimeter per second. What is the rate of its circumference? Okay, circle is that what the circle radius is increasing. The radius of the circle is increasing. Suppose r is the radius of the circle. It is increasing. Increasing is the rate of change of radius is given. So given quantity. Rate of change of radius with respect to what? With respect to time or what? Rate of change of increasing the radius of the circle is 0.7 centimeter per second is there. So that with respect to the time. So dr by dt is equal to 0.7 centimeter per second. Next, what we need to find? What is the rate of its circumference? So circumference we know that total circumference. Circumference we know that what we need to find? Rate of change of circumference with respect to the time only that we find. Circumference is denoted by s. Now we know that the circumference of the circle. What is the circumference of the circle? S is equal to 2 pi r. I just denoted circumference of the circle is s. Some people used to write it as a c. Nothing to worry. Anyway, now we need to find that ds by dt, rate of change of circumference of the circle with respect to the time. So that here it is sufficient to differentiating with respect to the time. What happens? ds divided by dt. 2 pi is a constant as well as coefficient of the variable r. So that r is the variable. Differentiation of r with respect to r is 1. But I am just differentiating with respect to time. So that dr by dt. Replace all the value. So what is the value? 2 pi as it is. Now dr by dt is given 0.7 into 2 pi. That means 1.4 into pi. This is the rate of change of circumference of the circle with respect to the time. Now, what is the unit? Unit is centimeter per second. This is how we have to solve. This is the solution. This type of problem might get for the 2 marks session. Now, next problem is this. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute, and the width y is increasing at the rate of 4 centimeter per minute. When x is equal to 8 centimeter and y is equal to 6 centimeter, find the rates of change of first one, the perimeter, and second one, the area of the rectangle. Okay, rectangle is that. Already know that rectangle which has 4 sides and opposite, 2 pair of opposite parallel lines. Okay, rectangle is that. I just name this rectangle as A, B, C, D is that. So here they are given the length x of a rectangle. Length of the rectangle, I just take that AB length is x. If AB length is x, obviously CD length is also x. Next, the width is given. Width y is increasing. Y is width of the rectangle. BC and AD lengths are y. Width I am just taking. Now it is sufficient to given data. What is the given data? Let's look on that. The length x of the rectangle is decreasing. Length of the rectangle is decreasing. Rectangle length is decreasing. That means rate of change of rectangle. With respect to what? With respect to the time or which quantity we are going to decide depending upon the given thing. That is 5 centimeter per minute is that means with respect to the time. So it is decreasing is that. Decreasing means compulsory we have to take it as a minus sign. Increasing means positive sign. Decreasing means we have to take it as a negative sign. Very important thing. So rate of change of length is given as a minus 5 centimeter per minute. If you mention minus, then no need to mention it increasing or decreasing, just changing. And if you have not mentioned any sign, positive or negative, it is sufficient to mention either decreasing or increasing with respect to minus and plus sign. Okay, next dx by dt is minus 5 centimeter per minute. Why it is minus means because of decreasing is that. Next, the width y is increasing is that. Width y is increasing. That means dy by dt is increasing. In which rate? 4 centimeter per minute. Next, when x is equal to 8 centimeter, when x is equal to 8 centimeter and y is equal to 6 centimeter, y is equal to 6 centimeter. In that case, find the rates of changes of the perimeter. Okay. First one is the perimeter. What is the perimeter of the rectangle? Perimeter is denoted by P. Perimeter is denoted by P. What is the perimeter of the rectangle? Total perimeter, that means x plus y plus x plus y. Simply can write as 2 times of x plus 1 because x plus x to x, y plus y to y, 2 is common. So 2 times of x plus y. This is the total perimeter. I need to find that rate of change of perimeter. So it is sufficient to differentiate. Differentiating with respect to what? Differentiating with respect to the time. Now what will get? So I just write here dp divided by dt is equal to 2 is a coefficient, keep as it is. Differentiation of x with respect to time, that means dx by dt, plus differentiation of y with respect to time, dy by dt. Now 2 as it is. Next thing, dx by dt is already given, minus 5 plus dy by dt is already given, this is plus 4. What is the final answer? Minus 5 plus 4 is minus 1. Minus 1 into 4 is minus 2. This is the dp divided by dt. What is the unit? Unit we have to mention it as a centimeter per minute. Centimeter per minute is over. Okay. Finally, we have to write the answer. The perimeter of the rectangle is decreases by 2 centimeter per minute. Perimeter of the rectangle is decreases by 2 centimeter per minute. Hence, the required answer. Next one is the second case. What is the second case? The area of the rectangle is that. I just continue here. Second case, area. What is the area of the rectangle? Total area is nothing but length into breadth. So length into width, area, that is denoted by A is equal to x into y. Length, area is equal to length into breadth or length into width of the rectangle. So now area is given by x into y. We need to find that rate of change of the area of the rectangle. So it is sufficient to differentiating with respect to the time. So differentiating dA divided by dt is equal to x into y. X is a variable, y is also the variable because sides are varying. So in that case, we need to differentiate. How? We have to use the product rule. Using the product rule, differentiate. Keep the first function as it is. Differentiation of the second function divided by dt plus. Differentiate the first function dx by dt, keep the second function as it is, u into v, product rule. Now we need to find that dA by dt whenever x comma y is given. What is the x comma y? X comma y is nothing but whenever length is 8 centimeter, width is 6 centimeter. That means 8 comma 6. So now replace x and y value. What will get? X value is 8 into dy by dt. Already know that. What is the dy by dt? Dy by dt is given 4 centimeter into 4 plus dx by dt is given minus 5 is that minus 5 into y. What is y value? 6 centimeter is that 6 centimeter. Simplify. 8 4 are 32 minus 5 into 6 30. 32 minus 30 is 2. So this is the required rate of change of the area of the rectangle, 2 centimeter per minute. It is a centimeter per minute or centimeter square per minute. It is a centimeter square per minute because length into width is that. So this is the required answer. Here area is increasing and perimeter is decreasing in this case. Okay. Hence the solution. The next problem is, yes, a balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon is increases when the radius is 15 centimeter. Okay. A spherical balloon is that. Okay, spherical balloon. A balloon is that which having the spherical is inflated. A balloon which always remains spherical on inflation. Okay. Is being inflated by pumping a 900 cubic centimeters of gas per second. Here they are pumping a gas. Gas is pumping inside the balloon, in which way the 900 cubic centimeters of gas per second. Per second they are pumping a 900 cubic centimeters of gas. So that means what is the given thing? Depending upon the unit only you can decide what is this given data. Here cubic centimeter is that. Cubic centimeter is nothing but it is a volume. So they are given the rate of change of volume with respect to what? Centimeters of gas per second. Is that the rate of change of volume of the spherical balloon is given as 900 cubic centimeter per second. Cubic centimeter can be written as centimeter cube per second. Value is given. Rate of change of value. Next, find the rate at which the radius of the balloon is increasing. Find the rate at which the radius of the balloon. Suppose r is the radius. Find the rate at which, that means dr by dt. So whatever the given thing is that in the data with respect to time or with respect to the radius or whatever, with respect to that only we have to take it. Here with respect to time is that, so that dr by dt we are equal to find. Find it is, find the rate at which the radius of the balloon is increases when the radius is 15 centimeter. Whenever radius is 15 centimeter, this is 15 centimeter. In that case, what is the rate of change of radius of the balloon whenever they are pumping 900 cubic centimeters of gas per second? So here we have already known that. Now let's how to solve this one. Rate of change of volume is here. We are required to find the radius, volume and the radius. So the volume of the spherical balloon depends on the radius. If the radius is increases, volume is increases. If the radius is decreases, volume is obviously decreases. So that it is sufficient to take the volume of the spherical balloon. What is the volume of the sphere? Spherical balloon means we can consider as a sphere. What is the volume of the sphere? Volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of the sphere. Now, here it is sufficient to differentiate with respect to the time because dv by dt is given. Now, differentiating volume with respect to the time. dv by dt is equal to 4 by 3 into pi is a coefficient. Constant is that, so keep it as a coefficient into r cube differentiation 3 into r square x power n differentiation is over. But here I am not differentiating with respect to the r, so that I am just differentiating with respect to time, so that here it is sufficient, right? dr by dt. Now is it possible to simplify? Check it. Okay, 3 ones are get cancelled. So find the value, or what we can write in the next step. 4 into 5 into r square into dr by dt is done. Now replacing all the values. Rate of change of volume is given. What is the rate of change of volume? It is a 900 cubic centimeter. Forget about the unit. 900. 4 by r is into r square is what is the r? R is 15 centimeter is 15 square into dr by dt as it is. Now, actually, we need to find the dr by dt, cross multiplying, shifting all these terms into left hand side. What will get? This implies dr by dt is equal to 900 divided by 4 pi into 15 square is that, I just write it as a 15 into 15. Simplify. What will get it as a, so 15 cancelling, check it. 15 into 15, 225. 225 into 4. 225 into 4 is 900. Okay, 900 get cancelled. What is the remaining value? 1 divided by 5. Or else you just manipulate and simplify when you get the answer. Okay, anyway. So 1 by 5 is that. What is this? This is dr by dt. So dr by dt is equal to 1 by 5. What is the unit? Unit we have to write as the centimeters per second. This is the required rate of change of radius of the spherical balloon whenever they are pumping a 900 cubic centimeters of gas, and the rate of change of radius is 1 by 5 centimeter per second. Hence the solution. Now the next problem is next one is a ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 cm per second. How fast is his height on the wall is decreasing that the foot of the ladder is 4 meter away from the wall. Okay. This is a word problem. Better to get on rough diagram. So ladder is there. So ladder is leaning against the wall. Okay, leaning against the wall is nothing but, if I can suppose it is a wall and it is a ground. Ladder is leaning against the wall. Okay, ladder is it is leaning against a wall. If I take an AB is a ladder. This is point I just take, or else I just take it is on the x-axis and this is on the y-axis. That means this length is x and this height I just consider as a y because they are not mentioning. Think about that. So let x denotes the ground length and y denotes the height of the wall. Okay, now we can mention that let x is the ground length and y is the height of the wall. Height of the wall. It is not necessary anyhow for your reference. I am just writing anyway. So ladder is away. Now they are little bit changing. How they are changing means radius and base. Once again, a ladder 5 meter. Length of the ladder is given. How much? What is the length of the ladder? 5 meter length is that. Is leaning against wall? Yes, leaning against wall. And one more thing, I just write here. See, we can observe that. What is the angle between the wall and the ground? The angle between the wall and the ground obviously a 90 degree. Other than this is not possible. It must be a 90 degree. At angle C, it is a 90 degree. Okay. Against a ladder is leaning against a wall. The bottom is nothing but a end point of the ladder A is pulling towards this side or right hand side of the A or left hand side of the A. So they are pulling, or else they are particularly mentioning towards C or toward our right hand side of the A. They are mentioning that the bottom of the ladder is pulled along the ground. They are not lifting along the ground only. They are pulling. How? Away from the wall. Away from the wall is nothing but outwards. That is nothing but right hand side. In this direction they are pulling. If they pull the bottom of the ladder away from this wall, then the B point is comes down. Now the next position, alternate position of the ladder is, I just write as a dash and the B dash. So again here it is a right angled triangle. They are pulling the bottom of the ladder away from the wall. How much are in a rate they are going to check it? Away from the wall at the rate of change of the bottom given. That already I just mentioned that this length is a x. So that can I take that the rate of change in the length as x with respect to what? With respect to per second is there, so that with respect to time, how much it is it increasing or decreasing? It is increasing, so that it is sufficient to take it as a 2 centimeter per second positive value. Next, how fast? Are you clear? The bottom of the ladder is pulled along the ground, away from the wall. Here it is wall. Towards the wall means you have to sit in this manner, but they are taking out away from the wall in this direction. Then the top of the ladder is comes down in this manner. This is the rate of change of x is given. Next, how fast is its height on? Yes, obviously height is decreases, height of the wall is decreases. How fast is its height on the wall is decreasing? In which rate it is decreasing? That means we need to find that dy by dt is equal to how much? Dy by dt is equal to how much we are required to find? Decreasing in which? Decreasing, the wall decreasing. When the foot of the ladder is 4 meters away from the wall. This is the foot of the ladder after changing or after pulling. This length they are given. How much it is? This length is 4 meters away from the wall. This length is 4 meters away from the wall. Away from the wall. In that case, what is the rate of decrease of the height of the wall we need to find? Very clear is that. Now here, how to find this one? Rate of change of decrease of the wall. So as they have given, the x value is given. Apart from that, x value is 4 meter, and the length of the ladder AB is given. AB length is given as a 5 meter. Then we need to find that y. So how to find the y? As we know that Pythagoras theorem, according to the Pythagoras theorem, what we can write? We know that the Pythagoras theorem, that is x square length, and this is plus y square, and hypotenuse as is write as AB square. AB square or else A dash B dash square. The length of the ladder has not changed. Now, instead of taking the AB square, can I write directly it is a 5 square, because the length of the ladder is 5 square is that. Now, x square plus y square, 5 square is 25. From this, we get a y value. So, I am just going to write directly the y value. What is the y value? Obviously, on the hypotenuse opposite side. There is hypotenuse 5 meter, adjacent 4, opposite side is obviously the 3, or else you can simplify to get the answer. So I am just writing it is directly y is equal to 3. If y is 3, x is 4, and this length of the ladder is 5 meter long is that. Now, apart from this, we can simplify. How to simplify this one means anyway. So here, instead of writing, I will directly write this y value, and here from this y is equal to 3. We can, it is sufficient to write this directly. Now, here I need to find the rate of decrease of the wall. So can I differentiate this value with respect to time? So it is sufficient to differentiate with respect to the time. If you differentiate with respect to the time, what will get? X square differentiation with respect to the time. That means x square differentiation is 2x. X differentiating with respect to, that is time, is dx by dt, plus y square differentiation 2 into y into dy by dt is equal to 25 differentiation constant with respect to time is 0. Now check it is. What are the quantity? We know that. We know that x value is known, y value is known here, and dx by dt is already given, and only thing unknown value is dy by dt. So from this we can write dy by dt is equal to, what is the dy by dt? Minus 2x into dx by dt, shifting all this term to right hand side, divided by 2. Here 2 to get cancelled. So dy by dt is equal to minus x divided by y into dx by dt. Now replace x, y and dx by dt. What is the x? X is 4. What is the y? Y is 3 into dx by dt is given. What is the dx by dt? 2 centimeters per second. 2, as now it is minus 8 divided by 3. This is the dy by dt. dy by dt is equal to minus 8 by 3 centimeter per second. Side length in terms of centimeter they are measuring, we can write as centimeter per second, or else we can write at the end conclusion the height of the wall. The height of the wall is decreasing. Height of the wall is decreasing at the rate of 8 by 3 centimeter per second. Height of the wall is decreasing at the rate by 3 at the rate of 8 by 3 per second. Here I just mentioned the word decreasing so that it is sufficient, right? Only 8 by 3. No need to mention minus 8 by 3. If you neglect this decreasing word, so the length of the or height of the wall is changing at the rate of minus 8 by 3 centimeter per second. Unit is very important. In the examination, you have to compulsory write the. So this problem very important for the 5 mark session. Most of the time prepared in the examination, and previous balloon problem, spherical balloon that is also most of the time prepared for the 5 marks session. So very important and very simple problem. Now the next one is yes. 11.1. A particle moves along the curve 6y is equal to x cube plus 2. Find the point on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Okay, it is a little bit different problem. Suppose the curve is I just take an xy coordinate, positive coordinate I am just taking a rough diagram, not a particular one. Xy coordinate is that. Curve is given equation 6y is equal to x cube plus 2. Suppose the curve is like this. Suppose, not exact diagram, suppose the curve is like this. So curve is suppose in this manner, but you have to take that y is equal to f of s. Instead of giving that, they are given y is equal to means 6 is dividing through, that will get to y is equal to f of x, y in terms of x. In this manner, curve is that. What we need to find? Find the point on the curve. We have to find how many points are there on the curve. There are infinite number of points are there on the curve. Out of that, one point value we need to find. How that point is there is find the point on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Out of this infinite number of points, we are required to find only one point. How that point is there is which y coordinate is changing 8 times as fast as the x coordinate. Suppose the y coordinate is changing. Suppose the y coordinate is changing from one unit. Then how the x coordinate is changing? How the x coordinate will be changing 8 times as fast as the y coordinate. That means changing is there. So on the curve at which the y coordinate is changing. Changing means we have to write as a rate of change of. So changing with respect to what? With respect to time itself. So that displacement we can consider that thing. So given that here y coordinate is changing with respect to the time. Y coordinate is changing as 8 times as fast as the x coordinate. 8 times as fast as the x coordinate. Read the sentence. Is it correct or not? Check it. The point on the curve at which the y coordinate is changing. Suppose the y coordinate is changing. How it is changing? It must be changes 8 times as fast as the x coordinate. 8 times of dx by dt. This is the value is given. Now x coordinate. What we need to find? The point at which point this condition is fulfilled. So that this is the given data. Now one more thing is given. 6y is equal to x cube plus 2 is given. So now dy by dt is here, dx by dt is there. So I just differentiating with respect to the time. If I differentiating with respect to the time, what will get? 6 as it is. This is the dy by dt is equal to x cube differentiation 3x square into dx by dt plus 2. Differentiation with respect to time of the 2 is 0. Now 6 times of dy by dt is equal to 3 exponent to dx by dt. Can we cancel the 3 ones are 3 2s are? Yes, obviously 2 times of dy by dt is equal to x square times of dx by dt is that. Now I need to continue. I will continue here. So 2 times of dy by dt is equal to x square into dx by dt is that. Replace any one of the value. I just replace the dy by dt value from this given data. If I replace the dy by dt value from the equation number 1, what happens? 2 into dy by dt can be written as 8 times as dx by dt is equal to x square into dx by dt. Now simplify this one. So what happens? Can I cancel the dx by dt, same quantity, cancel it. So 2 into 8 2 is 16 is equal to x square. X is equal to plus or minus 4. Here I am just going to take it as x value as plus or minus because curve is that curve might be extended whatever the quadrant. So either x is positive or negative. We don't know. Both values is satisfied. So if x is plus 4 and x is minus 4, what will be the corresponding y value? Because I am just going to point to point x comma y. X value is just quoted as a plus 4 and suppose x value is a minus 4. At this point also it might be satisfied. So that reason, if x is 4, then what will be the given equation? Given equation is star. What is the y value? Y value I am just going to write directly or better to solve. 6y is equal to x value is 4. 4 cube is 4 cube 64 plus 2, that means 66. Y is equal to 66 divided by 6, that means y is equal to 11. Therefore required one quantity is 4 comma 11. It is present in the first quadrant. Now similarly, if x value is minus 4, what is the corresponding y value? 6y is equal to minus 64 plus 2 because minus 4 cube is minus 64. Minus 64 plus 2 is minus 62. Left hand side 6y. Y is equal to minus 62 divided by 6. So what will be the y value? Minus. It is 31 divided by 3. So corresponding another y quantity is minus 4 comma minus 31 divided by 3. So these are the 2 points. Therefore they are asking that find the points on the curve is like. Therefore the required points are. What are the required points? One point is 4 comma 11 and another one point is minus 4 comma minus 31 divided by 3. That's the solution. This is also important for the 5 marks session. Now I just stop here. The remaining problems will continue in the next video. Thank you.